Okay, so we'll start with the electricity. In the electricity, we will first going to learn about the current. So current is charge per unit time, right?
Yeah.
Charge per unit time. It means whatever the charge flowing through a particular wire, if this is the wire, whatever the charge flowing through it in a particular area per unit time, that will be the current.
Okay.
Is that clear to you? So the
Yeah.
symbol of current is denoted by I. Is this thing clear to you?
Yeah.
The unit is ampere. It will be denoted by A, capital A. The
Okay.
formula of current is, the formula will be I equals to Q over T. Is this thing clear to you?
Yeah.
Here the Q stands for the charge that is flowing through it.
Okay.
The Q stands for the charge that is flowing through it in a particular time period. Is that clear to you?
Yeah.
So we can have the definition as, the definition of current will be, the electric current is expressed by the amount of charge flowing through it in a particular area per unit time, that is electric current. It is the rate of flow of charges. Is that clear to you?
Yeah.
So the definition we are going to have is I equals to Q by T. This is the formula where Q is the charge is in the coulomb, the unit of charge is in the coulomb, and the value of the charge will be 6 times 10 to the power 18 electrons. Is that clear to you?
Yeah.
And the charge, negative charge, is having 1.6 times 10 raised to the power minus 19. Is this thing clear to you?
Yeah.
So if we just find, there will be some formulas or there will be some numericals in which we have to find the charge. The charge is not given to us. So how will I find the charge? Just see here. See, the formula of finding the charge will be NE. Q equals to NE, where N is the number of electrons. Is that clear to you?
Okay. Yeah.
And what is the E? E is the charge on one electron.
Okay.
That is 1.6 10 raised to the power minus 19. Is this thing clear to you?
Yeah.
So suppose if there are 10 electrons moving in a wire, what will be the total charge? The total charge will be 10 times 1.6 into 10 to the power minus 19. So if we are going to solve this, it will be 1.6 times 10 raised to the power minus 18. Is this thing clear to you?
Yeah.
Okay, so after this current, we are going to do the second topic, that is electric potential and potential difference. Now this is also one of the most important thing we are going to do. Okay.
Okay.
So what is electric potential? Electric potential we can define as the difference between the 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another. Is that clear to you?
Yeah.
Suppose, wait a minute. Yeah, suppose we have one wire. Okay, from this wire we are just having the current. The electric potential is the potential difference between 2 points. So let's take the 2 points. These are the 2 points A, these are the second point, that is B.
Okay.
2 points in an electric circuit carrying some current. So if at point A there will be some charge, right?
Yeah.
See, this wire is carrying a current, so at point A there will be some charge. So
Yeah.
we need to displace this charge, or this charge should move to the point B.
Yeah.
So if we want to move this charge from point A to B, there is some work that need to be done,
Yeah.
right? So the work
Yeah.
done to move a charge from point A to B, that is called potential difference. That is called potential difference. So the formula comes out to be, see, the potential difference will be denoted by V. V is equals to W over Q. The potential difference will be work done to move a unit charge. Is that clear to you?
Yeah.
So this W stands for the work done to move a unit charge. Is this thing clear to you?
Yeah.
Yeah. Any doubts?
No.
Okay. So just see here, the SI unit of the electric potential difference is volt. Okay. Named after the Volta 1745 Italian physicist. 1 volt is the potential difference between 2 points in a carrying conductor. When 1 joule of work is done to move 1 coulomb of charge from point 1 to other. Is it called 1 volt? Is that clear to you?
Yeah.
Okay. Now see, this is the electric circuit diagrams that we have. So these are some symbols. So electric cell is denoted by this. If there is a battery, now battery is called a combination of cells. It is denoted by these. Now plug, open and switch. This is open and this is closed. Wire joint. Whenever there is a joint of wires, we will denote that by this. Okay. This is called resistance. You will need to learn the resistance more in the next topics. We'll read the resistance more. Now the most important topic that we have, that is Ohm's law. Now what is this Ohm's law? And Ohm's law is going to be the most important topic of this chapter. Okay, so just listen to me very carefully. Okay, now what is Ohm's law? Just wait 2 minutes. Now see here, what is Ohm's law? Basically, the Ohm's law, in 1827, a German physicist, George Simon Ohm, found out a relationship between a current I that is flowing in a metallic wire and the potential difference across its terminals. So the potential difference V across the end of a metallic wire in an electric current is directly proportional to the current flowing through it. It provided its temperature will remain constant. Provided that the temperature will remain constant. See, if there is a wire, the potential difference across the ends of the wire, the potential difference, if we check the potential difference at any point on this wire, the potential difference at any point on this wire directly proportional to the current flowing through it. Is that clear to you?
Yeah.
The potential difference at any point on this wire will directly proportional to the current flowing through it at constant temperature, given that the temperature should remain constant. Is that clear to you?
Yeah.
So see, now the potential difference is directly proportional to the current. If we remove this proportional sign, there is a constant that is coming, that is R. Now R stands for resistance. R stands for resistance. Is that clear to you?
Yeah.
So Ohm's law has given us the formula, that is V equals to IR. Is this thing clear to you?
Yeah.
Where V is denoted by the volt, the voltage, the potential difference. I, we all know that is denoted by the current, and the resistance is denoted by the R is denoted by the resistance that we have. Is this thing clear to you?
Yeah.
Okay, so let's understand what is this R now, because R is going to be the most important topic. Now the resistance. See here, the resistance is something that will resist the flow of current, or that will resist the flow of charges. Is that clear to you? Whatever that is resisting the flow of charges, that is resistance.